to be much clearer and better when it's uploaded into the website. Welcome to SOALIB Online Seminar Series. My name is Ijaz Jamil, founder and architect of SOALIB. I'd like to thank all of you for your participation in this event. This will be a 1-hour session in which we will discuss SOALIB for on-demand SaaS. If you do not have the slides, you can download it from the website. In this webinar, I will discuss and focus on SOALIB and how it can be used to build on-demand SaaS application. As you know, that SaaS means software as a service, where SOA means service-oriented architecture. The two are different. SaaS is a software running on the web, which is primarily using HTTP protocol and which can be consumed by browsing and using the particular website where the SaaS application is hosted. On the other hand, SOA is just an architecture on which SaaS can be built upon. If you have questions in the middle of the slides or anything, you can ask me. I will try to answer the question whenever I get a chance. To gain momentum in our discussion, I like to take a short tour of SOA. Modern SOA is a computing model based on loosely coupled interoperable services. Service orientation do add new requirements like discoverability. Services based on web services standards are discoverable. On the other hand, services based on REST is not discoverable, but certainly there are various protocols out there. For example, WADL, Web Application Description Language, is out there, which is not really a standard, can be used to discover REST services. In order for a service to work flawlessly without any association to any technologies used to implement it, services must be loosely coupled. Loose coupling is a very important requirement for a service to be totally interoperable. That means the exposed services must be stateless or have manageable state, which could be controlled by the service caller. The ultimate goal of the whole exercise of SOA is interoperability. In essence, interoperable means that an ideal SOA solution can be implemented with any programming languages, may be hosted on any operating system, may be consumed by any platform, and may support any protocol and so on. In reality, it all depends on implementation. Once that has been done, we call it a true heterogeneous SOA. In SOA, we are dealing with a system that with diverse operating environment, multiple operating system, multiple protocols, multiple processors, different programming languages. Speed of the network is variable, disparate databases, and just about any other possibilities you can think of. What makes web services ideal to cope with this heterogeneous integration is that the SOAP protocol is common and the format of the data within the SOAP protocol is also common. Because SOAP is a text-based protocol, it is understood by the most basic platform. This enables embedded systems to mainframe integration using web services. In this slide at the center is a heterogeneous integration bus. The job of this bus is to extract SOAP messages and wrap up with another protocol. This is the bus. And there are various protocols in here. Examples are HTTP, JMS, FTP, SMTP, various protocols which is used to transport messages. And this heterogeneous integration bus extracts a real message from one of the protocol, wraps up with another protocol, and use it, sends the message to another server, another service. This bus does also the routing. This bus knows which site, which IP address, which port location this particular service is running. And it routes the message based on what target service the message should be routed to. Now, next slide. This heterogeneous bus is called Enterprise Service Bus, or shortly ESB. This bus acts as a layer between services and has the job of translating the message format. So for example, if we got a SOAP message from a data service which intends to send to business process service, then each service have to pass through the ESB, where the job of the ESB is to extract the protocol from the extract the message from the underlying protocol, for example HTTP, and then reformat it to another protocol, for example JMS. So it can be routed to the business process service where it only accepts the JMS kind of messages. SOAP over HTTP and JMS is widely popular, but at many times SOAP over FTP and SMTP is also popular. In this figure, the common information to be into the XML, into the ESB is the XML formatted document. These XML formatted documents is wrapped inside various different protocols. So if we use REST, can we use ESB? Yes, we can surely use ESB with the REST services as well, because the REST services are HTTP based protocol, uses HTTP protocol. Next slide. In SOA, is it the right choice? SOA is a standards-based implementation of a basic XML-based protocol, and because it's a standard-based, that ensures a number of things. That anybody who wants to implement web services have to follow the standard. Thereby, anybody who is consuming a web service automatically can consume any other web services that is based on SOAP protocol. Web services have built-in discoverability that makes searching for available services easy. Web services description language, which we call WSDL, explains the service entirely. It explains the messaging pattern to be used. It explains what services are being exposed. So a WS document explains entirely almost the available features of the web services. Each service is loosely coupled. That means if there are balanced services, if one service cannot handle the load of one task, then multiple services can be exposed to balance the load. And because these are loosely coupled, balancing is going to be easy. Built-in support. Many programming languages, almost all programming languages can be used to support the client side of a web service. In most cases, the server side is multiple programming languages can be used to implement the server side. C, C++, Java, and C#. Java and C# are the most popular programming languages to implement the server side. C++ is used only in legacy system. It's not very popular. Data can be uniformly represented by XML. Obviously, data represented in XML format will be interoperable because XML formatted data can be read by any platform. XML is an extensible protocol, so if for some reason we want to extend some feature within the SOAP protocol, it can be extended. And this is the extensibility that makes web services so attractive, because new and well-known standards are coming out which attempts to standardize the entire web service protocol. It may be going out of hand right now, but eventually the entire goal of web services is to make the entire service-oriented architecture as a standard interface within WS interoperability standard. Once a web service is implemented, it is universal. It's a global thing. And there is no limitation on an application which cannot consume a web service. Now, what is the real advantage of a SOA application? In this case, I'm going to focus on web services. When I call SOA, I mean web services in this presentation unless I make some differentiation. In this slide, you can see there's a bigger puzzle, which is this puzzle here, the big one outside. And there are smaller puzzles. Now, what we are doing here is creating A and B, two web services, and exposing them out of the network. And these A and B is composed of two layers of services. In layer 1, there are services which cause another layer of service called layer 2. And these layers of services may be distributed across the entire internet. And the advantage of using web services to create more complex application based on other services is what makes web services attractive, because each of these are loosely coupled services. The maintenance cost of managing each of these services falls into the expert hand. That means that for example, a data services web service will be exposed by a data services company which is expert in data services. A data synchronization service will be offered by a synchronization service company which is expert in that field. So each of these services are exposed by experts in those fields, and they are bound to work very well when consumed by other services. And see, this entire big puzzle piece is a new service now, which is composed of other loosely coupled services, and those loosely coupled services are autonomous by itself. Now, this slide is a continuation of the ESB discussion we had just a moment ago. In the ESB discussion, we explained that ESB is a router plus translator, and the entire internet may be composed of a single ESB. If we think that a single ESB is shared by all the possible web services out there, this is how it look like. All the businesses share their ESB, and that ESB goes to the cloud. All the industrial applications share their own ESB and connect that into the cloud. All government web services connect to the internet through their ESB, and all consumer software services connect to the internet through their ESB. And on the internet, all these ESBs come together. That's how web services are exposed over the internet. Now, I'm going to explain it much more clear in terms of what really ESB means when it's exposed to the internet. Now, move on to the next slide. So on the server side, as you know, the SOA is mostly a service-based program which is mostly running in a server. This server must assure a number of things. It must be available all the time. It must not run out of resources. The bandwidth, as you know, if the services is consumed, the bandwidth will increase. The usage of bandwidth will increase. The server have to manage the bandwidth, so the bandwidth scales. That means the server have to automatically scale the system as more and more services are being consumed. The response time should not be such that there are more services being consumed and the response times is getting more and more increasing at a linear rate. We have to ensure that the response time does not increase if the services are consumed. So that means that we have to scale the system of services that's being called and make sure that the services are also working in a linear fashion. The complexity of the service should not be a concern for a consumer. The consumer should not know what is the complexity, what is the technology behind that service. Now, to do that, we have to take help of grid computing. This is a general idea of what grid computing is, grid architecture is look like in a power distribution system. In a power distribution system, this maybe there are a number of power sources. One of them can be nuclear, and that can be solar. It can be gas. All of these are feeding into the grid, and there are consumers here, which is consuming the services. As you see, if these two were not there, then the only power grid that is providing power is this nuclear power plant. If this nuclear power plant cannot provide enough power, one can add a solar power station, power generation station, and feeding the grid. And one of these consumers will have power from the solar. And same thing this wind. This is automatic scaling. If the consumer increases, the usage from other alternative power sources will also increase. And that's the basic idea of grid. Now, the same approach is used in cloud computing, where the grids are the network and the power generation station are the hosting servers. I think I missed one slide here. This slide is what I am at. This is the important slide. In this slide, we have a hosting service similar to the services, similar power station we saw in the previous slide. And the grids are replaced by routers. And there are power consumption units here. As you can see now, if this service consumer wants to call the service hosted by this server, then there is no way to get the source to here unless some kind of virtualization or some kind of methods are out there to call the other services. So the next slide will show you how to do the virtualization. In this case, we have two services. One is using two servers as virtualize two servers into a single server. The virtualization can be done in memory, in disk space, processing power, and bandwidth. So the processors, bandwidth, memory, and disk spaces all can be virtualized. There is a little bit problem here. All right. Scalability can be determined by using runtime governance. Runtime governance is a service in which the governance software will determine if a particular service is being loaded or not. In this case, for example, this consumer is calling service A. Service A depends on service B. But service B have multiple copies on the internet. If B on this business process gets loaded, there are other copies that you can run to process the information. And the way it can be done is by use of governance service. And this is the scalability part of service-oriented architecture. Now, this is how it works. In this case, service A is calling service B, but service B and server 1 is busy. So it routes to service B on server 2. If server 2 is busy, it routes it to server 3. If server 3 is busy, it finally reaches the server that can process the information, but it cannot process the server C side, which B depends on. So it calls another server which have C service running, and the C service is virtualizing hard disk as well as memory. So this example shows you that a service running on the web in the cloud does not necessarily mean that the entry point that you're using in your service is processing the job. The entry point that you are using may be an entry point to the ESB, but which service is processing the job, which server is processing the job will never be disclosed to you. It is internal to the system. Now, virtualization is a method by which resources made available by either creating, using physical resources or creating a simulated resource. Virtualization can be used in memory, disk, processor, or network. Now this is a very simple example of virtualization. We have 8 processor server in which we have these 8 servers, and there are many disk drives and also memories. And this is one kind of virtualization where we have used one processor, one disk, and one memory per virtualized server. And this one is a much more scalable virtualized server in which we have in the first one we have used 4 processors, 3 drives, and 3 memory segment. And the other one we have used 1 processor, 1 drive, and 2 memory segment, and vice versa. And that's all. So you can see that the virtualization can be done in both hardware and software. This is I'm showing you in both hardware and software, because virtualized processor is already available now. Pentium and Core 2 Duo after 2007 and 2006 are all virtualized, built into the hardware. In this slide, I have tried to explain how to virtualize services, how to really scale the services, build systems that's based on scalability and on demand. Now, our goal is to have these SOA services exposed on the web so that SaaS application can use it. We can build SaaS application based on these services. To build SaaS application based on SOA, we have to have scalable SOA, because SaaS applications will consume these web services eventually. To start with, we start with WSDL and deploy each of these services to independent virtualized servers. And we make sure that each of these virtualized servers are located at various locations, not in the same network. It can be in very diverse, geographically dislocated network. And then enable some form of service routing so that one service know the presence of the other service of similar type, as we have discussed in a few slides earlier. Now, as you can notice that to build a really scalable SOA, we have to have a very loosely coupled services. If we do not ensure loose coupling, then services cannot be made fully scalable. This is explaining data caching. Data caching is a requirement in stateful services where some services may be stateful, and stateful services keeps a short cache to reuse the data. Now, it doesn't have to be a requirement in any service implementation, but for some reason, people have used data caching to increase speed of the service, speed of execution of the service. Now, let's explain what is data caching. Let's say that A calls repeatedly B. Let's call that A calls B 2 times. And this numbers here is 1 and 2. These are the two servers in which B is located. These two servers are virtualized. In the first call, A gets into this service. A have no idea which instance of the service is being run. A simply calls a B service, and it's a router that transferred the control to either server 1 or server 2. And if it's server 1, then it uses its own cache to process the request, and then A calls B again, and this time it goes to server 2. Now server 2 doesn't have the cache of server B in server 1, service B in server 1. So it have a cache hit, so a cache miss. How can this be resolved? The server B have its own cache. It can request that server 1's cache be transferred to server B and service B in server 2, or service B can recache. This is an issue in SOA when it comes to scalability and when it comes to data caching. Data caching is required in many SOA applications to increase the speed of execution, because some of the time these data could be very large, very big in size, and doesn't make sense to recache the data if it's called repeatedly. Consider that if B is reading hundreds of megabytes of data from a data base, it doesn't make sense to read that hundreds of megabytes of data per call. It is always essential to cache that hundreds of megabytes of data inside the local cache so that it doesn't have to refetch the data every time it calls B. Now, runtime governance, as I explained before, that runtime governance can be used to determine scalability, and this explains a little bit more of what can be done in the design of scalable SOA. In this case, we have a governance service that's checking how the system is getting loaded as the processor is getting loaded. Now the B service, focus on the B service, and there are B services scattered around the ESB and also the internet. And governance service makes sure that the business process service doesn't overload because the B service has gone overloaded. And B service must be made available to process that information just in case the business process services B service is loaded. Then what will happen if it finds that the B service is loaded, it requests into the ESB to the scalable service to read out the data to another B service, another available B service which can process the data. So then B service request will be processed by another service here and then returned to C again. This is how it can be implemented by using SOA governance. And SOA in the cloud is really ESB scattered around the cloud using port and IP addresses. So these nodes you can see here may be considered as port on a particular IP address. And this imaginary path you're seeing in the center are maybe thought of a connecting line that knows all the possible and available port and IP addresses that have services exposed. There is no physical connectivity line like this in this orange colored connectivity line. There is no physical such line, but it can be assumed that you can draw a path from each of these available services, and you have the option to consume any one of these services in your path. And the consumer have its own node also, and the consumer wanting to consume the service will have to connect to a node, connect to the ESB, and then consume any one of these services that's available on the network. To consume, for example, A would like to consume the service of, this consumer would like to consume the F service, for example. Then what will happen is it goes through its own node, it traverses around to F's node and then consume the service, and the result of that data passes through these networks and comes back to the service consumer. So that's pretty much how the SOA works when it comes to consumption. Now this one is showing you a scalable SOA execution path. SOA services are executed by use of scalability as long as the services are scalable. So consumer 1 calls the service of A. A internally calls service B. Now B is scaled. That means there are two services instance servers that are hosting this service. B is not aware of that. A is not aware of that. But B implementation is scaled. And in this case, B calls C, and the C is also scaled. And C calls D, D is scaled, and F is also scaled. And see, this execution path works like this, eventually coming out. And which service is being consumed is not a concern for either of these services in which the implementation is done. Scalability is somewhat automatic. So how are we doing on time? Let's see. Okay. In this slide, service interfacing problem, we are going to quickly go into SOALIB interfacing because I think I spent about 30 minutes on discussing what scalability is. I would like to dive into a real topic, service-oriented architecture libraries, which can be used for SaaS application. Now I'm going to skip this slide, a few slides, and go into more into the SOA part, SOALIB part. Now this is orchestration. All right. The slides that I have skipped before are not related to SOALIB. It's more related to cloud computing, and I want to discuss more into SOALIB. So I will come back to those slides that I skipped if I have some time to discuss about those. SOALIB, as I say, that SOALIB is a service-oriented architecture library which have built-in many services built into it, which are all scalable, can be deployed in multiple application servers and supports various ESBs. Multiple operating system support, programming languages can be consumed, C, C++, Java, .NET. So SOALIB clients are already built for you. It's fairly easy to use these clients in any particular hardware platform. So hardware can be embedded systems down to up to the mainframe. The SOALIB services have J2ME API, which can be consumed from mobile phones. We also have working on a iPhone API, so it can be used from iPhone as well. I think hopefully by October we will have an iPhone API which can be used to consume SOALIB services. So why would somebody want to use SOALIB instead of building their own? A couple of reasons. SOALIB is based on standards-based. So if you are dealing with multiple standards-based services, which you definitely are if you're in the web services industry, and you want security implemented fully, you want to save time and development, and you have to, if you want to save time in building, testing, and then definitely service have a life cycle, and you don't want to have a service that you are consuming today and then later you change the service and it doesn't work anymore with the previous services. We make sure that all of our versions are totally compatible with the previous versions. So if somebody is using older services and then we have released a new service, we make sure that the new service is also compatible with the old services. So combining all these benefits, you will notice that the amount of time and money you're saving from SOALIB by using SOALIB is very large. Now let's focus on some architecture on SOALIB. SOALIB can support up to 24 database synchronization. The number of libraries that shipped with SOALIB is only 21. There are only 21 services that's exposed by SOALIB. And most of these 21 services are very, very useful services. Some of them are login, authentication, connectivity, database synchronization, file synchronization, and various other. I'm going to explain that in a couple of moments. So you can see that SOALIB has 24 database support. It operates on multiple operating environments. Operating environment means it works on pretty much any programming, any operating system. It can run on any application server, any J2EE compliant application server, and supports most of the programming languages on the client side, and we actually ship those API for the client, so you do not have to build your own client to consume the services. Next slide. As we discussed in the previous slide, that you can build your own service based on layering, and here you can use SOALIB service in your layer. So this could be SOALIB services, and these are your services. A and B are your services, and you can use your service and expose them and not expose the SOALIB services, and then build your own clients based on SOALIB client and ship those clients to your customer. So what you're doing is that by layering, there may be some of your service running here and some of the SOALIB service. You're building a very complex application. And the screen gets stuck for some reason. I don't understand this. Well, this now goes into more detail on what SOALIB is and what SOALIB services are based on. The SOALIB services have a number of core services, which you see on the left side, and number of utility services, which is at the center, and a number of services which is focused on a particular operation. For example, database synchronization and integrated service systems. Let's focus on core services. Core services include account, iAccount, iAdmin. These are two related with account administration. iAdmin is the account administration. iAccount is creating user, discontinuing a user, locking a user, that sort of stuff, mostly account management. Administration is creating users, deleting users, and allocating resources for users, various other similar things. iConnection is another service which can be used for connectivity, storing connectivity information for anything. It can be FTP information, database connectivity, JMS connectivity, any kind of connectivity, all stored in the same common format. iSecurity is mostly used for tunneling. When we use database synchronization, iSecurity used to create the database tunnel. iSOALIB is the information service about SOALIB, which can be consumed by any other third-party services which would like to request information from SOALIB. And iError message is a list of error messages that is returned by the service. And if a service returns a fault message, this error message service will explain that fault message. iUpdate is an update service which can be used to update the SOALIB libraries. And scheduling is the general scheduling library that makes schedule for any one of these services on the right side. So this schedule service can be used to schedule any one of these on the right side. The center one is utility services, nothing to do with any particular task. For example, iBalance is a load balancing service. iBatch is a batch processing service. Batch processing services, the services you see on the right side can be used, called as a batch, and this batch processing service handles that. iFile is a general file API which can be used to store or load files, save, rename, copy, move, various file operation within the server. iReport is a report generation API which can be used to generate HTML and PDF reports. iSocket is a web services version of Socket, which you can use to create server sockets to do some communication based on the socket from web services. iMessage is a messaging engine within SOALIB which can be used to send messages to other JMS servers and other SOALIB services. iMail is a mail API within the service, so it actually gives you the general mail API from the web service. You do not have to have a special connectivity requirement because the server makes the connection for you. This is the right side is probably the most important slide. You have it in this course. The database synchronization is one of the most powerful data services in SOALIB. It actually synchronizes heterogeneous data using a mapper-based synchronization, which iMapper is used to create the mapper. And during synchronization, data can be mixed with other data sources, which is exposed by iMixer. And these three compose the synchronization engine, and the iQuery engine, the data service reader. So iQuery, we can create a query to get SQL queries to generate results from various databases. We can delete, insert rows, update records, whatever. These are done all by the iQuery. iPayment service is the payment engine which can be used to process credit cards, debit cards, check cards. All of these are done by the payment engine. So if your company is wanting to process credit card payments through web services and your layered application would need a service that can process various payment processing, then this iPayment interface can be used. And this slide explains each of these functionality of the service. As I said, that the iAccount deals with account authentication, iAdmin with administrative tasks, connection with connectivity information. So I have already explained those. And utility services, as I explained, is related with particular implementation of the utility, specifically like balance, batching. And on the last slide, we have the data synchronization and integrated services. Now this is the API look of SOALIB. And this is the client side, and we have the service running at the center on any server. So we have the service running at the center, and there are various mobile client API and the embedded system C client, C++ client, and Java client, and .NET, which is C# mainly. All of them can communicate with SOALIB, and all the APIs for communicating with the with the SOALIB is already provided to you. Now, use in your own system. Why would you want to use SOALIB in your own system? Well, the first thing is that it will reduce your development and testing cost. You can take the product solution to the market very quickly. And it supports mobile platform to mainframe, embedded systems, PCs, multiple programming languages, and so on. As I explained before, that there are various things you can do. As I go to application, various application where you can use it, it will make it much more clearer. Now, let's look at the application. Example number 1. In this example, we have a mobile device would like to communicate with other mobile devices. As you know, that dealing with mobile system like cell phones would require that you have some kind of server running somewhere and is able to communicate with the mobile services, mobile devices. There are easy ways. Easy ways to do that is to create socket from mobile phones to a server. But if we use socket, then it's not going to be standards based. Using web services is going to be standards based, and web services, the SOALIB, in fact, can be used to access databases and files in the server. So not only that the mobile system can get access to all the files and databases and communicate with other mobile devices, it also makes the system scalable and interoperable. Let's look at number 3. There's one missing here in the middle. In embedded systems, C++ API can be used to build embedded point-of-sale devices. And then that point-of-sale devices can be can access databases. For example, let's say that we have a credit card machine which uses SOALIB. This credit card machine can access databases and directly insert data or retrieve data from the database using SOALIB API if the SOALIB server is running somewhere in the system. So third application is we have embedded application and mobile application, both of which would like to communicate with the mainframe. And as you can see that SOALIB is connected to the mainframe, and both embedded application and J2M application can access mainframe. And there's also 2 other kind of services, with third-party services and other third-party application which can also access mainframe through SOALIB. And this here you can see also that SOALIB is connected to databases. So pretty much any of these other networks other systems connected to SOALIB can use the databases. All right, sorry about that. Now, that covers the general overview of SOALIB when it comes to mainframe and embedded system. Now let's focus on data synchronization. How powerful the data synchronization of SOALIB is. SOALIB can synchronize one-to-many and many-to-one kind of database. Here you can see that we have source database 1 and source database 2 going to a single target database. Or you can have source database 1 going to 2 target databases, one target database 1, target database 2. So the many-to-one is source database 1 and source database 2 going to a single target database, that's many-to-one, and one-to-many is source database 1 going to both target database 1 and target database 2 during synchronization bidirectionally. And you can see that there are 2 arrows here and this one, that means that synchronization is bidirectional, and it's mapper-based mixed mode synchronization. That means that mapper, you just define the columns and columns to synchronize. It'll use those columns during synchronization. And this one shows you many to one form in which we have source database and target database, but we have two source databases in this case. This is showing you load balancing example in which we have embedded systems and mobile systems would like to communicate with the mainframe, but it passes through another SOALIB server to access it, and because these two SOALIB servers are load balanced. So the SOALIB server here and the top portion and the bottom portion are balanced servers. That means that anyone communicating with this one can use this server to access any other resources that's tied to this one, the bottom server. Now, so how easy is SOALIB to develop API with? SOALIB comes with 4 different kind of API: the J2ME, the mobile platform API, the C++ API for embedded systems, Java API for Java development, and C# API, which is .NET. The .NET API can be used with Visual Basic, ASP.NET as well. And we are also coming up with iPhone API within a few months. And that's pretty much concludes the presentation of this webinar. We right on time. We have about 4 or 5 minutes to discuss, answer any questions if you have. And this webinar is going to be presented and converted into webcast. You can see the webinar again if you missed the webinar in few slides, or if you cannot listen to me carefully, listen to me clearly, you can hear the same webinar again within 1 or 2 days. So that concludes our SOALIB for On-Demand SaaS webinar, and if you have any question, let me know. If you do not have the question, have a great rest of the week. I will look forward to hearing from you if you send us an email to this address, email. This is the email address you can send with any questions you have about SOALIB. And I will just wait for a minute to see if there are any questions, and then I can wrap it. Okay, one question was if I can go into more detail on what is loose coupling. Or loose coupling, I have to show you with an example. Let's work on an example on what really loose coupling is. And loose coupling is very important when it comes to service-oriented architecture, and one have to know very clear concept on what really loose coupling is. And I will show you what really conceptually loose coupling means. In this example, we have 2 services, and there is a third service which we call C, and A and B. Let's see that C is calling A. Now, loose coupling, how many ways someone can develop a software? There are going to be static variables that can be a class can be created with no static variable. A class can be created with drive caching. Some information may be stored in the hard drive, for example. If we can build a service which always behaves the same way with all the parameters and repeatedly calls. So if C is calling A 100 times, and the effect of calling the previous ones is not changing the behavior of the service. So for example, if C calls A first time, it changes some state of A. If C is called, A is called the second time by C, service A is loosely coupled if the behavior of first call does not change in the second call. Loose coupling enables system to be scalable because it doesn't differentiate between calls. All calls are thought to be identically and behave the same way. If A stores variables locally, A can store variables locally, and those local variables, whatever it may be, should not depend on how the A is called and how many times the A is called. It is based on instances. A instance is created. When C calls A, instance of A is created and instance of A is destroyed when C is no longer using that service. If C calls the service 100 times, each time there is an instance of A, and each time it gets destroyed when the second service is called. When the service 1 returns, the instance of A no longer exists. So let's clarify this. Did you understand, Marta? Did you understand what loose coupling is now? All right. Thanks, Marta. Basically, one thing to clearly think about loose coupling is that the behavior of the service does not change with repeated call to that service. That's loose coupling. There are many definitions on the web. You can find what loose coupling. People have said different things about that, but I'm telling you from my practical experience that to ensure that something is loosely coupled, think of if you can change the system state by calling it repeatedly. If you cannot change the system state by calling it repeatedly, then you have a loosely coupled system. Any more questions? Let's see if there are any more questions. It seems like that's about it. I think I'm also 1 hour ahead. I have other things to organize now. I have other webinars coming next week. There is one, you can go to the SOALIB.com website and see what other webinars are being offered. All of them are going to be offered this month. And if you are interested, you can certainly download the slides from SOALIB.com website. And let's go back to that site again, just in case you haven't had a chance to look at that. And if you have any question, send email to this address. And if you have any, if you want to review the webinar again, you can go to SOALIB.com. That site will point you to the right direction where you can find the slides. You have to create an account with SOALIB.com. And by creating an account, you can view other available webinars that has been broadcasted in the past. So it is now available as a webcast. So you can sign up and then view those past or webcast as well as this one, which we are going to upload it during a few days, over a few days. Well, have a good weekend and look forward to seeing you in the next webinar. Thank you.